In case you missed the last episode, we got the base, the frame, and the motor mount installed. Today on this episode, we're gonna have to fabricate some spindles so we can mount the go-kart tires to the frame. But before the rubber hits the belt, we gotta give away a mega square. So we're gonna have to hook this framework up to the scale and see how heavy this beast is. So let's do that now. Remember, closest to the weight of this whole assembly without going over gets the mega square. I'm gonna guess 650 pounds. I don't know if that transfers into kilograms, but 650 pounds. So let's lift this thing, let's see what it weighs. We got 276 kilograms, which transfers to about 608 pounds. It's pretty stout belt grinder, if I do say myself, and we're not even done yet. I think I want to add at least another couple hundred pounds to this thing. Why not? Sure, huh? So, if you're closest to 608 pounds, I'll be contacting you directly in the comments. I think before we get started, we should talk about what inspired this whole belt grinder build, and that's these go-kart racing slicks. Let's measure the overall height of the wheel and tire together, and that measures here on the surface plate 10 and 5/8 of an inch. That is the overall diameter we need to work with. The offset of the wheel center is 4 inches to the inside of this wheel. I wanted to see how much crown there was in it. There's quite a bit of crown in there. I'm probably have to experiment with air pressure to see if I can either eliminate or add some, but we do have crown in this tire, which is a good thing. The actual width of the surface of the racing slick that actually is contacting the road is 7 inches. So we need to make sure this wheel is center line with whatever we are designing for our platen. Okay, and now we can weigh it. So the wheel and tire weighs 5.3 pounds. It's pretty good. Nice and light. I don't even think I could make an aluminum wheel that would be that light. We have two different types of spindle hubs. One of them is the one that actually is going to drive the wheel, and this inside bore. You can get it in a couple different diameters, 1 inch, 1.25 inches. You probably could even get it 1.5 inches, I don't know. And the spindle that free rides has these 5/8 hole diameter and these bearings, and I think on go-karts they actually just weld a bolt to a steering hub and you can just use a bolt, really. So that's pretty easy. We're just going to turn something out of 1045 mild steel that I have over here. This is going to be the easiest, so let's just start with that first. Good fit. All right, we're at the point now where we got this top spindle turned down to size. We got this turned down to 5/8, which is what the spindle hub is for the go-kart wheel. And then I just eyeballed a taper in here to make it look nice. And the reason why I wanted to do this is because if anything were to change, if maybe these go-kart tires don't work, I'm able to replace it with something else at a later date. So I just drilled and tapped a 5/8 hole in the back so I can just bolt it through and thread it on like that. Okay, easy speasy. Now we can bolt this hub adapter on and off we go. So for the drive wheel, we're gonna drive it right off the shaft, okay? And normally if this was for a go-kart, it comes with this hub, but because of the offset of this wheel and the shaft length of the motor, we're about 2 inches short. So I'm gonna build an adapter that slips over this shaft and reaches the inside of this wheel to give us the offset that we need. I think this is gonna work out slicker than snot. And then we'll be able to put both wheels on and see this thing go. So I just pulled the shaft extension off the lathe here, and we're about ready to do a test fit. So the shaft extension just slips over to the motor shaft. It's a nice good fit here. Just like that. The original hub for the go-kart goes onto this section like that, and this hub adapter gets clamped on here. Got a little extra shaft to adjust the wheel where I want it, but now comes the problem of I need to make a keyway for the go-kart hub, and the problem is I need an internal keyway, a blind internal keyway for the motor shaft. This is a 1/4 inch keyway in the shaft, and I need a 1/4 inch keyway in the shaft extension. Problem is this is a blind hole, so I can't use a regular broach just to push it through. The shaper didn't come with any boring bars of any sort to be able to do this internal keyway work. I don't have any for the mill, so now's the time I think we're gonna just have to make one for this project, and I'll use it for other things. So let's get to it. I'm gonna use this 4140 bar, round bars, 1 inch in diameter. So I wanna use this 1/4 inch high-speed tool bit. Unfortunately, it's square, and the last time I checked, they didn't make square drill bits. So I need a square hole in a round peg. The best tool I think to do this in the shop is the water jet, since I don't have any square broaches in the shop. So let's go to the water jet and make a square hole in a round peg. I kind of did some close measuring, and I wanted to give myself a little bit more relief in that bore. So I knocked 1/8 of an inch off the diameter of this boring bar. And in the end, I just drilled and tapped for a set screw to be able to hold that high-speed steel drill bit in. So now I gotta make a holder to hold this broaching bar. It has to fit inside this tool holder right here in the clapper box. It's gonna look something similar to this, basically. We'll probably cut this on the water jet too. I think I decided on using this milling block. These are pretty cheap on eBay. I'm going to be sacrificing it for this project, but these accept 5C collets. This one happens to be a 1 inch, and you can get any size in these just about. So if I do ever want to change the boring bar, I can just change the 5C collet, but basically it goes in there like that, and then this collet squeezes down on the boring bar. So, and on top of this block, I'm gonna weld this basically tool post so I can lock it into the shaper, okay? I wanna weld this thing perfectly square and 90 on top of the block. And I don't want it twisted, because if we have it twisted, this bar is gonna be kind of sweeping in at an angle. I'm gonna try to get it precisionally welded so I don't have to take it to the milling machine and resurface the whole thing. So here's my welding setup. I have the magnetic shims that we sell. This is a perfect application for that. I'm going to be holding the block on top of the shims to get the right offset, and then setting it up on here just like that. And now I know I'm perfectly centered on this block, and I will clamp it down to the table and we'll weld away. So that's what we're going to do next. So let's get with it. Went to go put the new tool holder in the tool post, and wouldn't you know, the thickness of this was actually too wide by, it was like 1/8 of an inch. So I ended up taking it to the e-mill and slabbing a little bit of clearance off. So now it slips up inside here pretty easily. And then we can tighten it down. The cool thing about it is the 5C collet just slips right in still and gets used just like it normally would to be able to grab onto the boring bar. Because this has a taper on it, it sucks it up tight. All right, let's make a keyway. Okay, right. time for the test fit. Let's see, I need a key. Let's do a key first. There we go. Perfect fit. That's it. Locked down. Let's tighten the set screws. Sweet. This has a key too. Is that cool or what? If I remember right, the belt size is 6 by 89. Cool. It's gonna be so sweet. Let's put the belt on. The motor isn't bolted down. Get a first look at it anyway. Pretty awesome. It feels like it has a good tension. Pretty good. I don't think we're gonna need to add more than that. Oh man, that's looking cool. Any of the Fireball tools in this video, I'll have them linked in the description below. Now that the wheels are done, we can finally get to the platen. Thank you for watching. I'll see you in the next one.